Today we're going to learn about calorimetry. Calorimetry is the science or act of measuring changes in energy. Calorimetry is performed with a calorimeter. Right? So in order to measure the heat energy changes, the change in temperature is measured. Okay? Along with the change in temperature, we also will measure the mass. Okay? And we use the equation Q equals mc delta T, or MCAT. Right? Again, this equation is found in your reference table. And if we look at our reference table, we will find that it also tells us what Q is. Q, of course, just like in the last video, we learned that it was heat, right? And it is measured in joules. M, of course, is mass, and it is still measured in grams. C is what we call specific heat, and is dependent on the substance. So every substance has their own specific heat, and that has units of joules per gram degree Celsius. And then delta T is the change in temperature. And this time we're going to measure temperature in degrees Celsius. And the reason for that is because in specific heat we use degrees Celsius. Right? And when we find delta T, we always do the final temperature minus the initial temperature. Okay, to find delta T, it's always final minus initial. So we have some special constants for water. Again, these are found in your reference packet. Okay. So the specific heat for liquid water is 4.184 joules per gram degree Celsius. And the specific heat for steam is 2.02 joules per gram degree Celsius. And the specific heat for ice is 2.05. That is missing here. Ice is 2.05 joules per gram degree Celsius. And again, these are all in your reference packet on the front page. Just like yesterday, Q is positive, it is endothermic. If Q is negative, it is exothermic, meaning it is releasing heat. Alright, so let's try a couple problems. First problem, determine the amount of energy. Alright, so we're looking for the amount of energy, we're looking for Q. That's required to increase the temperature of 50 grams, that of course is M, of water from 50 degrees to 100, and that's going to give us our delta T. Right, and since we're talking about water, we would need to get our specific heat from water. Okay, so Q is the amount of heat energy. That's equal to our mass times our specific heat times our delta T. Right, so Q is equal to 50 grams times our specific heat. Okay, and if we're talking about water and it's at 50 degrees, then it's liquid water, so specific heat would be 4.184 times delta T, again, final temperature minus initial temperature, so 100 minus 50, right, and then we solve for Q. And we get 10,460 joules. Again, it's positive, so this would be endothermic. Again, we know it's endothermic because our delta T was positive, temperature increased, so heat was added in. If we look back at our significant figures, right, we have 3 significant figures here, 3 there, and 4 there. So we need to round our answer to 3 significant figures. So our third significant digit is this 4. So we can round it up, so it'd be 10,500 joules would be our final answer. Alright, so in problem 2 it says to calculate the specific heat. This time we're looking for the specific heat. And remember the specific heat was C, right? And we have 500 joules, and joules, remember, was Q. And then 5 grams, right, that's our mass. And then our delta T is our change in temperature. All right, so again, Q equals mc delta T. So Q was 500 joules, and that's equal to our mass, which was 5 grams, times our specific heat, which is what we're looking for, times our delta T, which is final, minus initial, right? And so then we solve for C. And we get 20 for our answer. And since we were looking for specific heat, our units are going to be joules over grams degrees Celsius. And again, the reason why we get that is because here, right, we're dividing these over here. So we divided by 5 grams, and we divided by 5 degrees Celsius. So when we simplify our numbers, right, all of our units, none of them cancel out. So you have joules over grams and degrees Celsius. None of them cancel out. All right, so let's take a look at our significant figures. Here we have 4, here we have 2, 3, and 3. So we need 2 significant figures. So we can write this as 20 with a decimal point joules over grams degrees Celsius, so that we can have our 2 significant figures. And that is the end of today's video.